at the top of engineering design is art. Really good engineering is indistinguishable from art. It's just there's something that speaks to you deep within your soul. It transcends your day-to-day. It like breaks you out, snaps you out of it. And you're like, wow, like that is actually cool.
Welcome to Talking Design and Engineering from Makelab, a podcast about insights and advice from industry leaders driving innovation and shaping the future of people, processes, and technology from the world of physical products.
Hi, I'm your host, Cinerita, and this is Talking Design and Engineering. And today with us, we have another special guest. We have Rich from Partsimony. Welcome, Rich, who's making a comeback for season 2. And how have you been?
Great. Yeah. Season 1 was great. I'm glad the show got renewed.
Yeah.
Thanks all our sponsors.
And we're excited to have you back as well. And since the last time you were here, tell us, how has Partsimony been? Are there any changes happening? What's up?
No, it's been a really exciting time. It's I think the last one was pre-AI boom.
Yeah.
It was just like around when ChatGPT was like becoming like a really big thing. Since then, it's been really exciting. I would say, I can't say too much publicly, but there's been a lot of like development going on internally. So we're able to move like 10 times as fast. Things that we used to like dream about doing, we can actually get it done now, which is exciting. Finally, like bridging, and we can talk about this later, but like bridging the gap between the engineering and the manufacturing and the supply chain. It's like really exciting for us.
Yeah, and I want to hear all about that. But before that, let's also touch upon things before AI, right? So as a mechanical engineer, I want to touch upon how was it working in the mechanical engineering or manufacturing space, and what were sort of the challenges you felt?
Yeah, so I'll say, so at the beginning of my career, I was in an aerospace, a large aerospace company.
Yeah.
And I was a process quality engineer for high pressure turbine airfoils.
Wow.
It was a long way of saying just helping manufacture parts that help people fly.
Yeah.
Right? And one of the things as an engineer that would frustrate me is you get a part on the shop floor, and my job was quality, right? To make sure that we can actually produce things at rate. And you get a part and you're manufacturing and you're like, why is the quality so crappy?
Yeah.
Like it's designed to a degree where it's like, if we just change this feature, it should make my life much better. We can actually like produce this thing with better yield. We can also find more suppliers who can actually manufacture this part. And they don't have to deal with scrap and a lot of quality issues. And there's this like long feedback loop, right? Where it's, you design a part, you go to the shop floor, you try to make it, you learn, you go back to the engineering team and you make those iterations. And before AI, I think it's like really painful.
I can imagine.
Post AI, I would say is still painful, but less painful. Well, what I mean by that is, I think AI has really good convincing demos I'm talking about engineering right now. And specifically, I'm talking about designing and engineering. Right? So like, think of like text-to-CAD or something, right? I don't think we're there yet today where it's fully automatic.
I agree.
Right, it's like, oh, it looks great, but wait, the bars are coming this way, and it's like, how are we gonna actually make that, or can actually survive the stresses you're gonna put it through? So it's one of those things where you still need the expert and expertise, an expert in the middle, right, to make that final call. But I think it's less painful in the sense of like, you can speed run some of the like analysis. So some of the things we're focused on at Partsimony is, how can we take any design and figure out the right way to manufacture it? Or whether it's, castings, forgings, additive manufacturing, what specific type of additive manufacturing you want to use for the given part. So those are things that kind of excite us, where going back to my days at the aerospace company is, how do I shorten that feedback loop of, before I even go to the factory shop floor, I know the right way to make this part, or some issues to actually change the design to actually make this part.
So back in the day when you were in aviation, what manufacturing processes did you work with?
Oh my gosh. Pretty much the usual suspects, like the CNC machining, additive manufacturing, like metal, primarily metal, because like aerospace, castings, EDM drilling, so like drilling the holes in the airfoils, and then some like interesting like inspections, like X-ray inspections, like destructive and non-destructive. But one of my fondest memories was going back, how did I end up in manufacturing? I senior of college. I went to Georgia Tech undergrad. One of my buddies was like, do you want to make money? I was like, yeah, of course. Of course I want to make money. Like, who doesn't?
Sign me up.
No, I want to be perma poor. I'm kidding. But everyone wants to make money, right?
Yeah.
And so I was like, yeah, let's do it. And he was like, there's a thing called investment banking. You should totally do it. And if you're an engineer, you're really good with numbers. Like, long story short, did an internship at a Wall Street investment bank here in New York City.
Yeah. No, because I was stalking your LinkedIn for research purposes, and I see like manufacturing and all that, and I'm like, this is interesting.
Like, where is this?
How does this actually work in?
Sin, I lost my way. I got caught up in the money. I got caught up. Yeah. But the funny thing is, so I that summer, like, I remember that summer was like one of the most like fundamental summers. Like, it was fun. I worked really hard. But at the end of it, like, I got a full-time offer.
So you were good.
Yeah, I try not to suck. I try to be good at what I do. Maybe it's like the Nigerian immigrant mindset where it's like, what is A minus?
Yeah, it has to like we need to hustle, need to get the top of the top. Like, exactly. It's like cannot settle for mediocre. I'll get a call from my mom. What did your friend get?
Exactly. No. So I had to get an offer. I couldn't go back. So I get the offer, and I'm like agonizing about it. I'm like praying about it. I talk to my dad. I talk to my friends, and my dad has this saying growing up. Who's like, love what you do. Love what you do to the point where your worst day is Friday because you're not going to be working over the weekend, and your best days, your most exciting days, is Sunday because you can't wait to go to work on Monday. Wow. And so I turned down the Wall Street offer. I know, what an idiot! What an idiot! You turned down Wall Street, and the funny thing is, I felt more at peace turning it down than when I got the offer. And I was like, well, what am I going to do now? I had an intern at the Aerospace, and I was like, okay, I'm probably going to go back. And when I went back, I did the operations leadership program there. But I remember my first role was in a manufacturing plant in Madisonville, Kentucky. Now, if you're not familiar with Madisonville, Kentucky, not a lot of tourists go there. It's kind of off the beaten path, very quiet. It's kind of one of those towns where one of the funny things is I show up to work on a Monday, and when the operator's like, hey, were you at Walmart? Like yesterday, it's like, yeah. But I didn't see you. It's like, oh, my neighbor saw you.
Wow. Yeah. So like a small town.
Yeah. Wow. It's a community.
Right.
Yeah, it's a community. And I remember just being in Madisonville, Kentucky, and my buddies from banking were like, bottles and models. And I'm like trying to make sure the yield for this turbine airfoil is right. But yeah, that was really exciting. But I just loved it. I love making stuff.
I think that's the mechanical engineer.
Yeah. By the way, I want to ask you this question as well. But what made me excited about doing it, engineering degree in the first place, was, I don't know if you remember the movie Flubber.
No.
So it's a Disney movie. I highly recommend. Robin Williams. It's this green blob. It's mad scientist inventor, just tinkers all day and just makes stuff. And I watched the movie as a kid, and I was like, I want to be that guy. I want to be the guy who just tinkers in my garage. I can see you cringing. It's okay.
No, because I'm thinking, because I have a similar story.
Really?
Yeah, because when I was 13, before that, I wanted to be a botanist. I was like, I'm gonna do plants and shit like that. And,
no way.
At 13, I saw Iron Man, and I'm like, this is what I want to do. And that's how I got, my essay for my grad school started with a quote from Iron Man, because I'm like, that is what inspired me, and that is what I'm going to put in my essay.
Oh, that's so awesome.
So I get that. No, I get that. In my mind, I was
I totally respect
relate
that.
So hard
I respect that. Yeah. So I want to be Iron Man.
Exactly.
But no, it was that's what kind of got me back into manufacturing. And then it was my personal frustration of seeing things being designed and then going to the shop floor and dealing with those issues. And then I eventually went into the supply chain side, where I was basically doing supply discovery or negotiations with suppliers, and seeing how engineering decisions were reverberating through the entire supply chain. I was like, there has to be a better way to do this. And basically decided to start Partsimony with my twin brother, who at the time had a very cushy job. So I turned down my investment banking offer, but he took his offer.
Okay.
He sold out. Roland, why? I'm kidding. No, he found his way back.
He was an engineer too?
He was an engineer.
Okay.
Civil engineering.
Okay.
Real Bob the Builder kind of guy. I'm kidding.
He was inspired by something the other year.
He was inspired by Legos and Bob the Builder. I'm kidding. But no, so our dad is a civil engineer. Mm-hmm. So we just grew up around engineering. And so, yeah, he decided to do civil engineering, but then went into banking. Yeah. But he's back on the engineering side.
Nice. So you get lost and find your way.
At the end of the day, if you do anything in life, might as well like what you're doing.
Yeah. I agree. So, we all envisioned, when I was a kid, I would think like, 2020, we'll have flying cars and something like that. But back then, what did you think the future would be?
That's such a good question, because especially as like another technical person, like you had these dreams of like what the future looked like. I always thought like would have flying cars by now.
I know.
But what's funny? Yeah. Technically, we kind of do. Technically, they're just like helicopters. It's like you have this like so I saw this like video, which I'm sure you've seen, of this like car that goes on a tarmac and then flies off, but the wings fold, but it just looks like an airplane with folded wings. It's just like, but then you see really, really crazy things like, not to nerd out too much, like quantum computing.
No, you can.
Yeah, sweet. I'm in good company.
I love that.
Like, I actually think things like AI and quantum computing, like at the math level, is very, really interesting to me. I think another thing I was thinking about is like robots. Having like a cool robot, like hangout where you can like build your own robot, like have a robot companion to do really cool like adventures with. But what's interesting, when you think about what was happening today, there is actually some sci-fi already happening. Like, I think SpaceX is crazy sci-fi. It's pretty cool. I think what's happening in quantum computing is pretty cool. I mean, AI is pretty cool. It's like sci-fi. And there are things like super sci-fi like materials and how materials behave. I think there's some really interesting things happening in the material space where there's like energy and stuff like that. Like, I think that's pretty exciting.
Yeah, I think that's pretty cool too. And even like, this is really good for anyone who's super nerdy. And I was like, oh my God, there's like computing. We have so much more faster computing now and everything is happening. But also for someone who's not that nerdy, or like for my parents, for example, just for them to be like, hey, do this for me. And the AI just does it. That's huge for them. That's like, what do you mean it's just gonna do it, Huge. That's huge for them. So yeah, I agree in a way that
this is the star. I don't know if they
the MVP.
Now they can see.
Like, give me the mic.
Hello everyone. This is Moo, and this is B-roll. Actually, no, we should keep this. We should keep this.
This is actual footage. Yeah, he had a small cameo role, and he's back. He's like, not too much. So then fast forward to today, and now that AI is taking over, when was that moment where you felt like, everything's changing now?
That's a good question. I would say it was December 2025.
Wow. Okay, that's specific. Yeah.
Okay, so the reason I'm specific is every year, every December, I take 2 weeks off, like Christmas, and I choose something I want to like learn and go deep on. I'm a real nerd.
I think.
And so the year before, I redid linear algebra and the math and statistics behind AI, because I wanted to understand the math behind the actual like models. Oh,
so the algebra that goes
exactly the math
into making
the
AI.
vectors and everything.
Oh,
right. I know. I have a problem. Because like I wanted to know deeply like how it actually operated.
Yeah.
I mean, there is some fuzziness to it, but there's just like the math behind it. And then this last December, I was like, okay, I'm gonna go in on like building with AI. And I'd done in the past, like where there's like building like little projects or whatever have you. And it was previously, it was not painful, but it was like a lot of like hallucinations. Like, I meant this, but you're doing this instead, right? But last year, something clicked where I was like, it's actually work, right? It's actually like doing what I actually envisioned or kind of like had in mind. And I think it's just progressively gotten better and better. Where I feel like if you have a real big problem in your mind and you can distill it in a way where you can kind of chunk it out like an engineer would, you can get at least a workable prototype. Now, scaling into production is a different story, but you can get a workable prototype to potentially save you from doing something manually.
Yeah.
Yeah.
So it's like helping reduce all the time. So then would you say that it's helping engineers in engineering or other things? Like, there are getting quicker at the non-engineering stuff, or not even that, like analysis or just compiling things.
Yeah, they're great companies who are using AI to speed up like analysis and like have different permutations and run in parallel to figure out like what's the right engineering. I'll still say that we are not there, at least for mechanical engineering, we're not there at the same level as software engineering. Like software engineering, you can be like autopilot. I don't think you'd be autopilot for like mechanical engineering just yet, or electrical just yet.
I think this is also something I mentioned briefly in our last episode, actually, that we still need an expert in the seat, giving it sort of boundary conditions to operate within, 100%. Rather than just letting it do its own thing.
100%.
Yeah.
And I have a slightly counter unpopular take.
Okay.
Right, where people are like, "Oh, don't learn to code. Coding is solved." But I feel like you should know high level. I think you should know like the logic and have some sense of what you're working with. 100%. Because I feel you cannot go into this blindly. 100%. Yeah. Yeah. For those listening, do not give AI your entire computer. It doesn't work out well. Not saying I'm speaking from experience. Okay. I'm just saying I know a guy. Oh, okay. A guy. Yeah. Yeah, no, I agree completely, because I feel I am still at that point where AI still scares me a little. Yeah. And so I feel like I still need to be in control, where, like you said, I'm not just giving it my entire computer or like my whole... Exactly. Here's my social security number, bank documents. Yeah, just take everything. Exactly. No, I don't think I trust that. And that's why I'm like also scared, like what am I getting into here? So I'm still a little skeptical about it. I think it's interesting. I think it's going to build trust over time. I think it'll be interesting to see. So one thing that I was thinking about was like, and you kind of like alluded to this, where it's like what sectors would see AI adoption faster. I think things like education would see like... That's a huge... Like imagine the stuff they were able to learn now that you'd have had to watch 10,000 hours of YouTube videos to distill just like 3 paragraphs of this content, right? Or like, not to bring up childhood trauma, but I wanted to learn so much growing up. Yeah. And I was frustrated by some of the teachers I had, where, some teachers actually like teach because they love teaching and they understand the content. And some other teachers may not even know the content and just like regurgitating something. Yeah. And you can tell the difference very clearly. Yeah. You can tell the difference. And I had a lot, like I had some really good teachers, but I had a lot of experiences where it's like, if you could just like distill this for me, I want to learn this. Like actually just explain this. Like I see the paragraph. You don't have to read the paragraph to me. Can you explain it a different way? And then you take me along and it kind of got better. And I think with AI, I think it's just much, much better. Much better. Yeah. No, I think the AI boom sort of happened when I was still in grad school. And that must have been interesting, brother. That was interesting, but also it was so weird because sometimes, yes, like, to get clarity on some topics, I would sort of be like, hey, explain to me this better. And I would do that. But at times, and it was just the very beginning, right? So there were times when it would just give me things that wouldn't make sense. And I'm like, actually, I don't think that's right. I was like,
you're right. Now listen, let me rephrase. And then it will give me something.
Cites
and then,
a research paper. It's like,
yeah,
I don't think that research paper is real.
I don't think,
You're correct.
yeah, you're correct. And I think it was also like back then when there was like an year limit, like, oh, it's only gonna give you info before like 2022 or something like that. So I was like, you know what, it's fine. Look, we'll wait for it to get better. And it's gotten better now. And it's gotten so much better.
You know, it's interesting. I was talking to my wife about this. I'm like, do you actually need to get a PhD now?
Mm-hmm.
You know what I mean?
Yeah.
Unless you're working on something super niche.
Yeah.
But like, what's the point? You know?
Yeah. What did she say?
Well, we're gonna live in the farm. No, but I actually think I think PhDs are still valid. I think they're gonna be less PhDs because I think there's gonna be just less interest in people even wanting to be a PhD in the first place. I think there could be more like doers, people like doing things.
I agree.
It's pretty exciting.
Yeah. It's like more accessibility, right? Like I don't need to enroll into a program now. I have like everything.
I mean, PhD is brutal. I mean,
it is.
Yeah.
I have friends.
Yeah, it's brutal.
Yeah. It is. No, I just had a flashback.
I can tell. It's like,
oh, I should check off this one friend that I have. So do you think AI is changing an engineer's role, or is it just changing the tools that they use? So is it just that the tools are changing, or the role itself is evolving? Now, this is what an engineer is expected to know.
I would say like it's more so the tools are getting better.
Yeah.
Because I feel like the tools are getting better and engineers are kind of getting unleashed. What I mean by that is like, as an engineer, there are like a lot of crazy ideas you might have in your head, but not enough like bandwidth to actually explore those ideas for one reason or another, right? And some of these tools help like speed up that ideation process.
Yeah.
Where it's like, oh, I can easily go from A and now explore B and C.
Yeah.
I don't think the role per se is changing, at least for now.
Yeah.
I think mechanical engineers are safe. You know, like sometimes I see these like, you know, text to CAD tools and they're really great, but it doesn't replace the engineer.
Not yet.
Like, you know, but yes, not yet.
Not yet.
Not yet. Not yet. I think, you know, at the grand scheme of things is like, what does an engineer do? Like what value does an engineer bring to the table? I think a lot of it is like judgment, taste, and like nuance. You know, like for example, some of the best like engineering designs is like biomimicry, like or taking something from biology and adapting it in a mechanical sense or whatever have you. That to me is really novel. You know, like it's hard to prompt, you know, like make this based on the way a cell motor like operates and like mitochondria like decomposes or composes. It's like okay, but the engineer will actually understand nuance and kind of design something like that. So I think the bar for what can be done with engineers is just going to go up, which is exciting. Because going back to your point of like sci-fi, I think hopefully you can see more sci-fi now because people are actually getting better tools to actually unleash them. Yeah.
And I also feel like, you know, like you said, the nuance and the creativity that an engineer gets. Because I think I was reading something the other day and it said that, you know, like AI is always gonna look back and because it's a learning model. It's gonna take from. But I feel what then as an engineer is like the creativity, the new things, the nuances. That's what an engineer's help bring and then collaborate with AI. And, you know, so anything that's already been done, that's already like all these logics, they're there in place, all these processes are already in there. So AI is just like pulling from different sources, right? Yeah. So that's what it's going to do. And so when it comes to creating something new, I feel that is up to the engineer.
100%. Like if you imagine like this cup of water, right? And all this stuff that AI has been trained on is the water in this cup, right? But if you're trying to, I don't know, create orange juice, right? For example, in a bottle, right? That's a completely different context. Yeah. That sure there might be derivatives that might be housed in this data of water, but it's still something very unique. It's something very, very unique. And I think to me, that's a human ingenuity that is actually the premium
Yeah.
Where it's like, oh, like you can think in a different way that actually makes no sense in the context of water, but makes a ton of sense in the context of like juice or whatever.
Yeah, I think I agree with that deeply. I feel another thing that engineers do is designing for failure, or like having that margin or that factor of safety.
That safety factor.
What is your take on AI doing the same? Do you think AI is there yet where it's like trained on those sort of nuances?
So there's something that we think about a lot of Partsimony, where it's like, at the end of the day, you want something that's consistent. Because what we focus on is like developing a solution that mission critical teams can rely on.
Yeah.
And for that to happen, you need something that's like constantly north.
Yeah.
Right. Like if the answer is 5, don't give me 2. Just only give me 5.
Yeah.
Right. And so the way we think about it is there's the AI, which is like the LLM that people like to call, right? Or the model. And then you have like the tool sets or the MCPs or whatever that the model can plug into. Yeah. What we focus on is how do we build the tools that both the human and the AI can use to be very deterministic. So mission critical, like engagement, you can go back and see why a decision was made. And you can actually audit a decision as you're making it to make sure it makes sense.
Wow.
So for example, when we look at manufacturability, if we're recommending a specific manufacturing process, you can actually go through the logic of why this manufacturing process is being recommended or why this is a failure or a cost consideration. It's really well documented and it's deterministic. Because what you don't want is, today you ask, hey, what's the best way to make it? It's like, 3D printing. Yeah. And then the next day it's like, oh, did we say that? Oh, definitely.
Let me rephrase.
Exactly. It's like, you're right. Forging. It's like, it shouldn't change. It should just be consistent.
Yeah.
And so like, I think for us, at least at Partsimony, it's focusing on how do we build the tools that is deterministic, that both the AIs and the human beings and experts can use. And then we can always plug in like the AI on top of it to, try to marry the context between. Yeah. So like, I see the AI as like a context helper, if you will, right? Where it's like, oh, here's the additional context. Yeah. But like the tools, the infrastructure, there's like the consistent like mode where it's like, you know where you're going to get, you can audit it. Yeah. You can have a plane fly knowing that, the analysis was done. Right. Like imagine as an engineer, if you're like, failure analysis, like your FEA was AI and it just changed. Yeah, it's just like, the stress over there, that's fine. That's fine. It's fine, exactly. So it's that kind of stuff that we think about is like, how do we make sure that something's like mission critical and you can depend on it and you can make actually like mission critical decisions from that. Yeah.
And I feel that's when AI will really start impacting sort of manufacturing, but also these industry like aviation, defense, like high tolerances, everything needs to be precise. And I feel until it reaches that standard, like you said, we still need an expert. So then everything nowadays is being like AI this, AI that, AI this. So I have 2 questions related to this. First, what do you think is being oversold? Like AI is still not there yet, but everyone's like, oh, you should try AI for this in engineering. Have you come across anything like that yet?
So it's interesting. Within engineering or within supply chain? I think
supply chain
engineering. I would say I think what's oversold is going to take your job today.
I agree.
Today.
Yeah.
Yeah. I don't think it's there yet. Because I think what people miss when they say comments like it's going to take an engineer's job or a supply chain manager's job is that they usually distill that job to one specific thing. Yeah. Right. So for example, if it's an engineer, it's like, oh, now that we have text to CAD is going to replace all mechanical engineers. No. CADing was not the whole job description.
Yeah, we do much more.
Exactly. Right. And then, or if it's a supply chain manager, oh, now that we can do supply discovery, we don't need supply chain managers. Like, no. You need to understand nuances. For example, like even if a supplier says they can do part A, it doesn't mean they can do part B and C. Or if they say, it's going to be 2 weeks, as a seasoned supply chain manager can think, no, it's really going to be like 4 weeks. Yeah. Like I know the supply really well, right? Yeah. Or, the things that people don't really understand through the data is trust and relationships. like a lot of supply chain managers build a lot of trust relationships with the suppliers and vice versa. And there's a reason why a supplier would give you a more favorable payment term or lead time is because of the years of history of trust working together. You don't replace that with AI. Right. At least in the short term. So like when people say like, you know, AI is going to replace an entire role, I kind of chuckle and was like, you know, that's cool.
That's cool that
like,
you think
but,
that.
like, the role is more than just that one specific task. Yeah.
And then, okay, so I have a take on, again, where AI is being used and how it's being used. I feel there's also a lot of like, while we're doing great progress with all the actual problems, I feel there's also a lot of like clutter in the sense that a lot of problems, like things that like you're solving where there is no problems. People are just solving for the sake of solving. What's your take on that?
That's a really spicy question.
Yeah.
I think there are definitely lots of problems there. Problems being solved.
Yeah.
I have a very interesting take. Okay, so I don't know if it's interesting or not. I'll let you decide. But my take is some of the problems being solved are almost solved for like, they're trying to solve for like B instead of A. So what I mean by that is like, we were talking about sci-fi earlier. They're trying to go to a sci-fi future, which is B. But then the real problem is A today.
So they're like skipping a step?
Yeah, they're trying to skip a step. So like one of it would be, for example, Jarvis.
Yeah.
Everyone wants a Jarvis system. Everyone wants like, you know, I just like, and like it just tells me like I've invented time travel. Right?
Yeah.
What does that look like? It looks like a bunch of different tools. Some of them named Jarvis. Right?
Yeah.
But it's like, is that a real problem today?
No.
Right.
No.
And but is it worth working on? Probably. Yeah. Maybe.
Yeah.
Some no for sure.
Yeah.
Some no for sure. But some of them are like, okay, like I could see if you perfected this, B is gonna be really, really good and then game changer.
Yeah.
But I feel like there's this is just like my founder mindset is you need to survive that valley. The valley of just like
trial and error
before B actually works out. So almost like the best way and the way we think about it is just like, let's solve for A. And then as we're solving for A, build for B in parallel. So the things that we're thinking about in Partsimony, they're like super moonshots that we haven't even like announced or anything.
Yeah.
But what we're doing right now is just building the foundation for that.
Right. That's like some sort of foresight needed.
Yeah. And usually I think is one of the benefits of like having been in the problem, right?
Right.
You kind of like tell what's a real problem, what's like sci-fi and just like a nice to have.
Yeah.
Yeah.
Okay. Yeah, I get that. So let's talk about Partsimony and bring us to that world. Partsimony sits at the center of like manufacturing, supply chain. So you see data, you see bottlenecks. Where is AI actually moving the needle for you guys?
Yeah. So, okay. So for us, it's about stitching the context between engineering and manufacturing, an extension of that supply chains. And so where we see reducing the bottlenecks is how do you actually understand the context of a design or a part as it relates to like the manufacturing environment to the supply chain environment. So I'll give you an example. It would be like during COVID, right? We supported a team making EU approved ventilators, right? And so for some of the components, you know, what components makes the most sense to 3D print? And if they're going to be 3D printed, who are the suppliers or the facilities so it can just 3D print the part, right? Makelab, you know, they can actually make the parts they actually need, right? Yeah. And so for a lot of you know, like large companies, these are silos. It's like your engineering silo, your manufacturability, your like machinist, kind of like engineer, or your operations engineer, and then you have like your supply chain manager. And to get everyone in the room, it takes a lot of effort. Like you might share an email thread, but it's not the same, right? And so what we focus on and where we use AI is bridging the context of a design down to the actual shop floor, down to supply chain.
That makes so much more sense because I feel that's where most of the miscommunication happens, that the one side doesn't see the other side completely. Right. And I feel bridging that gap could help so many problems.
For example, like even for Makelab, before an order comes in, can you tell them, hey, this geometry is not going to be good. I know it looks like a wonderful piece, but it doesn't really print well.
Right.
Or it could print, but there's a high failure rate.
Yeah.
Right. I feel like even just that feedback is really important for even the engineer or designer to like, okay, cool. Like, even if I still want to go through with it, at least I know what reality is. Yeah. And so if there's a failed print, I'm like, I already knew it was going to be failed. Yeah. Like, it's fine. Like, I'll wait.
Managed.
Exactly. And a lot of times, a lot of the frustrations come from missed expectations. Like, hey, I just thought you waved your magic wand and like the parts are here. Yeah. Right? Like, what do you mean there's a delay? It's like, well, it's actually a long print. Yeah. Or it is. It's a pretty big part. Oh, it is. It's that whole thing is this feature actually makes it harder on the yield. If you actually changed it to a different feature, maybe it's more curved, less like 90-degree angles. You can actually print better with less support. It's like a key insight. Yeah. And so for us, one of the exciting things we see about AI is also helping even the younger engineers operate like senior engineers, right? Because a lot of times, like, it takes a level of just like decades of expertise to just like be with it, right? And so what we're doing in Partsimony is how do we help everyone in the org operate like a 20-year veteran in the engineering or manufacturing space or an actual supply chain space. And so that's what we're talking about, like the tools as being the foundation. How do you actually build the tools that even the expert in the AI finds helpful in doing the day-to-day job?
Yeah, I think it's like an age-old problem or frustration. You ask any engineer, either on either side, design, manufacturing, they'll just complain about how, like, oh, the design team wants this, but this isn't even manufacturable.
It looks wonderful in CAD. It looks really nice. Really beautiful.
Put in so much
effort. Not manufacturable.
Love that. Sorry to break it to you, but not manufacturable. And I think it's great to hear that we are sort of able to bridge this gap with AI now. And I think I look forward to.
And I think an extension of that, like really cool things I think are going to be made.
Yeah.
We're going to spend less time, hopefully, firefighting, less time on the frustrations and more time actually doing the cool stuff, which is like making stuff.
Yeah. I agree. You work with defense clients as well. I like to believe that that's a whole different a whole different ball game, right? Like there's like tighter security, there's tighter lead times, higher stake. So do you think AI operates differently in that space versus like a commercial supply?
Yeah, 100%. Like I would say, so there are multiple ways to address this.
Yeah.
So I'll talk about like the infrastructure, and then we can talk about like how it affects specific teams, right? So I think just for defense or just aerospace in general, or just large OEMs in general, the first layer is just security.
Right.
Where at least for the stuff that we focus on with defense is you have to be able to be deployed. They call it an air-gapped environment, like in a top secret where it's like nothing goes in or out. It's just it's somewhere in a basement bunker, and that's where the application lives, right? And then when you go above that, how does it affect the teams and how the teams use it?
Yeah.
One of the biggest things you focus on is making sure things are mission critical or reliable.
Yeah.
Like trust is something that we take very seriously.
Yeah.
And so how do we actually have the tools be trustworthy where you can actually audit them and audit like why a decision or recommendation is being made, right? And then for the engineering team is more so focused on manufacturability use cases. What does it make sense to actually change your design? Even if you're working some top secret project, how can we actually leverage our engineering skill sets? And then on the supply chain side of things, a lot of customers who start to serve now, like either make things internally or they work with external suppliers. So there's like make versus buy trade-off where it's like, hey, I may even have a 3D printer, but it makes sense to go to Makelab for this part, right? Maybe the 3D printers I have in-house already have max capacity. Or, for different reasons, I just want to go outside. Or maybe I want to go inside. And maybe cell D7 has a machine that's available with enough uptime.
Yeah.
And so what we focus on is like, how do you bridge that gap so you can go from design all the way to manufacturing, supply chain, and one seamless thread, but then have that feedback loop that learns on itself, but then still have the expert being able to audit.
Yeah,
right?
yeah.
To make the final
Always an expert in the loop.
Yeah.
And then you talked about trust, and one question just popped up in my mind is, are you or have you experienced any skepticism from, let's say, the older generation? Do you think they're reluctant, or are they as on board with incorporating AI in their workflow?
Yeah, like it's funny. When we sell to like larger OEMs or experts, we actually don't use the word AI. It's kind of like a dirty word. It depends. We just show the use case, and for us, it's about the use case being the compelling sales pitch, where it's like, okay, I want that outcome. Like that outcome is compelling to me. How you do it is almost irrelevant.
Yeah.
Because what I've found is when you say AI to expert, their eyes just roll over. Here we go.
Yeah.
Another AI tool.
Back in our day,
Exactly.
walked like 20 miles or whatever that is.
And rightfully so, because and a lot of them have been burned.
Yeah.
By people promising AI is going to solve everything, and it really doesn't.
Yeah.
At least today.
Yeah.
And so we focus on just what's the compelling use case, and how we deliver it. It doesn't really matter. Yeah, like so when an expert is like very like skeptical about something, it's usually because sometimes they can just do it themselves, right? So it's not like the tool doesn't work. It's just like, yeah, I can just do it. Well, DFM, like I know DFM.
Yeah.
Like I don't need a tool to tell me this is not a machinable feature. But it's kind of not about that, right? The real problem is you might retire, and the other person replacing you may not be as seasoned of have the 20 years of experience. So in some sense, it's not about the individual expert, it's about the organization as a whole. And how does the organization have the infrastructure that learns and adapts and maintains mission critical like excellence without having to rely on Bob or Sally not retiring? You know, which is typically what happens today. Is you have the 20+ year veteran, but they're not going in their seats for too long, right?
Yeah.
And so that's what we kind of focus on, is like, how do you distill the message as being received, where it's, you know, they're actually right. They can't do this 100%, but they might be leaving, right? But the problem that we're trying to solve is not that. It's not, hey, Bob, we're going to replace you. That's not the problem we're trying to solve. The problem we're trying to solve is, how do we help the organization at large operate like Bob at his level of expertise, or Sally at the level of Sally's like expertise.
And then also I feel another related take to that is a lot about, oh, this is making engineers lazy. But I feel...
Yeah, because engineers have a huge problem with laziness.
Yeah, like, no, like, I could do this. Why won't you just do this yourself? But I also feel it's not about that. It's about efficiency. I could either work and do it myself and spend hours on it, or I could, cut short that time and do many more other things. So I feel it's a matter of efficiency, optimizing your time.
Do you want to know an interesting stat?
Yeah.
So they did this productivity study on AI and AI productivity, specifically for like software, right? Engineering. And they actually found out that engineers are actually spending more time coding than less.
Yeah.
Like, why is that? It's very interesting.
Yeah.
And like, typically, if there's a lot of effort, so imagine like a quadrant of like high effort, low effort, high impact, high reward, low reward, low impact, right? People always focus on low effort, high impact.
High impact.
Right?
Right.
And then you basically debate. Okay, fine, we'll go to high effort, high impact, but it has to be really mission critical.
Yeah.
Right?
Yeah.
But now, because of AI, the quadrant really almost doesn't matter. It's one prompt away. Yeah. Right. And in some regards. And so what ends up happening is you just have a lot of like scope creep and bloat, which leads to your point earlier, is people build solutions for non-existent problems. Yeah. Right. Yeah. And so it's like, productivity wise, people are busier, but they're busier doing the things that maybe they should not be doing. It's the AI is actually generating more work, and sometimes you have to clean it up. Right. It's like, okay, well, like, now we have this like massive code base, but like we really need just these 3 features, right? Or like we've actually duplicated the way we're doing this specific thing across 5 different times because it's 5 different separate prompts or 5 different separate sessions or whatever have you. So in a way, it's like it's really fascinating where people think like AI is gonna yes, it's going to help with productivity, right? But you still have to have good judgments as an engineer or a supply chain manager, like where should we actually allocate our time and resource and effort, and what problems actually are worth solving. Just because it's now easier doesn't mean we should actually do that.
Right. Yeah. Now, do you think that it's gonna get saturated?
I think there are going to be lots of tools get developed, right? There's actually the interesting stat that I heard recently where the number of apps went up. There's like a chart went up significantly, but the number of reviews tanked. Fascinating, right? Usually number of apps, number of reviews go like kind of like hand in hand. Exactly. But what's interesting is like people are creating a lot of like, lack of better words, AI slop that people really use. And I think it's going to create this like fatigue, right? In the end user, where it's like, it's going to boil down to trust at the end of the day, where it's like, if you can trust an application to work reliably, if someone else tomorrow has another application, you wouldn't necessarily care. And you know, it's interesting. That's one of the things we also found within Partsimony. Which is when you're selling your solution to an incumbent, there's a sense of like beyond your use case and your success stories and what you can provide for the customer. And in some regards, they don't even care. Well, what matters is they don't get fired. Like, literally, what matters is I'm not going to look stupid for vouching for your new solution. Trust is the most important thing, right? And this is why, like, when you trust is extremely hard to get, very easy to lose, and a lot of like call these like AI solutions these days focus on just like ramming something through with a really nice demo. It's like, cool, you made the sale, but if it doesn't work, you're breaking trust. And so it's like it just, the way I see it is like it's better to go slower.
You need to pick and choose what you want to like take down first and perfect before moving on to the next thing, because I feel AI has also given us like the speed, right? Oh, I can do this, and I want to do all of it all at once. But I feel we need to just like double down, do one thing, and then move on to different things, because I agree the trust is important. I think that's what sells in the market too, right? Like consumer, like why would you prefer one brand over another? It's trust.
100%. Like I'm a huge Makelab fan. Shout out to Makelab. Huge Makelab fan.
The plugging.
Oh yeah, I mean I have to. Makelab is great, but I feel like what makes Makelab so good is the obsessive. I'm not gonna out you guys too much. The obsessive nature of just like process and quality.
We love that here. Like we know that.
Actually, I mean, I'm not gonna do therapy right now, but you guys have a problem. You guys are too obsessive, right? But I feel like that brings trust, right? It's like, okay, cool, I can go to another service, but I know the level of like obsession you guys have, so I'd rather just go to Makelab.
And we love systems and processing and
now you know
I can stop.
Now you're like, out to yourself.
That'll be a whole different episode. So then, what's the future? Because I feel for me, even 5 or 6 years ago, I didn't think this is where we'd be. You know, because I was like, okay, AI is, you know, we had machine learning and we had artificial intelligence, we had Siri, and we had all that. But to see that we would reach here and so soon, and I feel it's been exponential. Like even 6 months ago, you know, there's a
difference.
There's a big difference. So I am not sure what the future looks like and what's next. Like what can be better than this?
You know what's interesting? The future is uncertain. I can't predict the future. But I think the one thing that I think is going to matter the most is critical thinking and curiosity. And so what I mean by that is like, I think what AI is going to show is that at the end of the day, what actually helps with success is people who have really good taste and judgment, right? And like I was talking about this with Christina, where it's like I feel like people who understand design and engineering, primarily design, like good designers, have an unfair advantage with AI. Like if you know what needs to exist, how it needs to exist, down to just obsession of like a user experience, of how an order gets made. That's actually incredible insights. Like you can't really prompt. That gives you an edge. But I feel like the more you can focus on just the curiosity of like random things or things that like are not necessarily part of like the norm, I think the more you can actually just like have a wedge. Like if you, for example, if you want to create an app that just grades Pokemon cards, it's probably a market for it. Right? Like, but you have to be obsessed with Pokemon cards and like
you need to know
everything. Exactly.
the user. You need to know everything. And I think, this is something we actually talk all the time at Makelab, because Christina, I know she's talked about how she's made all these apps, and I feel so much of it works and really hits and really helps us is because there's this vision behind it. There is this sort of like direction.
The designer mindset.
I think that really sets it apart, because, you know, I don't remember for what, but I think it was like some random thing I was looking up online and it directed me to this website. And I'm like, this looks
horrible.
I have no words. It was obviously made using AI, but it was like every other website made by AI.
By the way, I'm actually curious. At a side tangent. What are it's hard to communicate, but like what is the telltale signs or the giveaway where it's like this AI? I'm curious if mine aligns with.
I feel cohesiveness.
Like different fonts
and different random, like there's no palette, it's just whatever happening. Another thing is knowing your user, or knowing, I don't know if that's the right word, like ergonomics, but not like when you're at screen, you know, what's intuitive, what's like, okay, after I do this, clicking here makes most, like if I'm placing an order at an online portal, right, after I put in my order, my eyes naturally like I would expect so like intuitive, like I feel that thinking and what's missing here. If I'm a user, this is where I'm gonna get confused. You know, having that insight, I feel sets it apart, because I feel a lot of what people are trying to do is just, I can make a website with AI, and they'll just make a website.
Make no mistakes.
And they'll put in all this prompt and they'll take what AI gives them. But I feel something, again, this is out of a conversation I had with Christina again, you need to push back. I was like, no, give me better. Give me this. This is what I want. You need to be really picky. You need to be really like, you need to know what you're doing.
By the way, what you're talking about, that's the expertise you're bringing, right? So that's the thing that like you can't, like the AI doesn't really know. Like you have to have the expertise. You actually have taste that you've cultivated over years. It's like hard to replicate, and that's your competitive edge. Because like another person can get the same prompt and it's like, this is good, this is great.
This is great. Why should we? I don't care. There's like yellow and purple and everything happening, and I don't care. The exit button is like right there. Cannot even see it.
Not like you actually care about it at all.
This is great. But I really believe like understanding the pain points. I think that's huge, and the direction. So like you're just directing the AI. AI is gonna do the work for you, but it's like making a movie. But if the director's shitty. You can have like an Oscar-winning actor, but
it's true.
If the direction's not good.
I was actually just thinking, like, what would I even look like an actor? Is like, God, no, we can't use that. We can't use that. It's like,
but what are your points? Like telltale signs.
Telltale signs. Mine is a little bit more subtle. It's like a lot of neon lighting. Have you seen that?
Yeah, now that you mentioned,
super ultra bright, vibrant.
Yeah.
I'm like, can we just tone this down a little bit? Everything is highlighted in different color codes.
They're like these rounded boxes.
Oh yeah, you know the rounded boxes.
I've had my fair
neon
share.
Highlight rounded boxes. Yeah.
Do better.
Yeah. Now that was said, it's like people are gonna adapt now. It's like the M dash of design.
It's like no neon boxes. Where people would like put no M dashes here. That's why I feel like in the future, if like 10 people are going online asking AI to make a website, you're getting similar results by default, unless you give it some direction and give it like specifics.
Something new.
I wonder if that changes, or it's always going to stay the same, or that's always going to be like one drawback of AI, because AI learns on things it's been trained on. So is it always going to do however advanced it gets?
Yeah. It's actually a good question.
Yeah.
Like I feel like we're gonna realize. I think we're gonna realize it's kind of like having like Microsoft Word or Office or Excel. It's like we all have the same tools.
Yeah.
But if you're someone who's like really trained at it, there are people who can actually create Excel games.
Yeah, I've seen that, and I'm always amazed. I'm like, I cannot do that.
Wild.
But
like I'm over here doing additions, subtractions, divisions. These guys are making games.
I'll have
like,
trouble doing like sum.
Just like some like,
bracket. Oh,
like,
backspace. I'm just gonna edit manually, actually. Yeah, no, they do that, and they'll just use keyboards. Won't even use the mouse, and I'm like, you're a wizard.
100%. So I feel like there are going to be people call them like prompt engineers now.
Yeah.
But they're going to be people who just know how to get that 1% out of the models. But I think even beyond that are the people who are experts in a domain. I feel like there is going to be a return of like hobbies and side quests, which need to happen. We need to have more side quests, more hobbies. If you look at a lot of like innovations or a lot of the breakthroughs, they're kind of like side quests. Steve Jobs going to India, like we wouldn't have really good fonts if that didn't really happen digitally.
Yeah.
Like it took someone who's like, you know what, like fonts matter and we should actually have good font, like typography. I would say like if we're going to be super philosophical here, at the top of engineering design is art. If you look at engineering, it's indistinguishable from art. It's just there's something that speaks to you deep within your soul. It transcends your day-to-day. It like breaks you out, snaps you out of it. And you're like, wow, like that is actually cool.
I feel it's like when you said that, it made me think immediately of like, like space exploration.
Yeah.
That can be like a giant side quest for humanity, or but it furthers our research and advances so much. Like so many technologies that we have developed, so many materials that we have developed have come out of that research. And in the end, it's like, it fills everyone with like so much joy that, there are like 4 people out there on the moon right now. That's so much hope and joy. Cool. And I love that so much. Coming to my favorite section.
Oh.
Let's do the segment I like to call Talking Shop. Okay. I'm going to do quick rapid fire questions and you can answer quick or not quick. Or
the fifth. I'm going to...
Are you ready?
Let's do it.
Okay. One engineering task you'd never let AI make the final call on.
Design.
Okay, that was quick. One tool or process you wish AI had existed for back in the day.
Ooh. A tool or process that I wished...
Like, you think AI would benefit, or that process would benefit the most from AI.
Oh, yeah. Okay, so okay, I have one. Yeah. So basically, we've done this thing recently where it's like having like adversarial AI panels debate different approaches.
Oh.
Right. So for example, it could be a feature we're developing or something.
Yeah.
Right. You have one AI panel that's like, oh, this is the right way to do it. Another AI panel is like, no, this is the wrong way because X, Y, Z reasons.
Yeah.
I think you get better distilled outcomes and solutions because you're like speed running that feedback cycle. And you're like bringing to light things that like you may not have even thought about.
Yeah.
So like some of the things I think about you from an engineering perspective is like, for example, we have this like manufacturing intelligence system internally, and it basically analyzes like 9 different manufacturing processes at the same time. So you're basically speed running the ways to manufacture a process. Like I wish I had that earlier where it's like you can just like like a Monte Carlo, like the Marvel people, like the like Doctor Strange, where it's like looking at different like that meme, just that for like engineering, like supply chain, where it's like you can look at all the different permutations, like no, this is the winning path.
Okay. Simulation when AI is involved, or physical testing, which matters more?
I think before you get into customers' hands, physical testing. Before you ship, definitely physical testing. I think when you're in the prototype phase, just simulation. Don't do physical. Don't waste time.
One thing engineers need to understand about AI that most of them currently don't.
Ooh. But it's funny, like engineers are naturally like skeptical. I think in some aspects, it will help not to be so critical. I think being open to
change.
Yeah, no, I will phrase differently. Open to exploring dead ends, because I feel like as an engineer, like you don't want to waste time on things you think are stupid. It's yeah.
I feel even the way we are taught in school is like, you have limited resources, you have, all of this is limited, so you need to make the best of what you have.
Exactly. So, make the best decision constantly.
Yeah, like economically and like
you're super optimized.
Yeah, like that math meme.
Exactly.
I was like, okay, this is a little mediocre than what I wanted, but this is fine.
100%. And I feel like as engineers, we should explore just nonsensical side quests.
Yeah.
Because I think as engineers, I feel like some of the fun stuff, like Mark Roper, right, the YouTuber, right?
Yeah.
I love his channel because just like some of the stuff is just like fun.
Yeah.
It's like, is it rocket science?
No.
But it's super fun. Exactly. Like, I feel like we just need to have more fun.
Yeah.
I feel like a lot of engineers are very serious. We tend to be very serious because the job is serious. And it affects people's lives and stuff.
Yeah.
I feel like we should bring back fun
fun.
Exactly. Bring back
tinker
fun.
More.
Exactly. Tinker more.
You mentioned as a kid you saw Flubber and wanted to go into that. What do you think that kid would think today?
That's a good question. I think that kid would be surprised. I think the kid would be surprised. Basically the way Partsimony happened was I had a dream senior college for this device. Built was in my dream and actually worked. So I was able to get like the utility patent. I got a utility patent on it and everything. And because of it's in military space, I had to go to this like, what's ITAR? What's all this like government requirements that if you mess up, you can actually go to jail. Like extra control laws and everything. And I was like, I'm not a big fan of jail. I'm not a big fan of $1 million fines. Yeah. And that's what kind of like eventually led to Partsimony. I think the little me would be very surprised and like pretty happy. Where the little me would be disappointed is I currently don't have a tinkering garage. It's on the list. One day
we'll have more fun.
I just want to just have a garage or a tool like just a workshop to just build stuff and tinker. Before I die, I want to at least one of the side projects I really want to explore is like robotics. Like I want to just create a robot because I think it'd just be really cool.
I think that tinkering workshop is most of mechanical engineers dream, because I feel even me as a kid, I would see my dad and his like little toolbox and so cool. All of that. And I was like, when I grow up, or not even that, even like when I was in school, I would be like, okay, I want to have like just my tools and like just sit and tinker and build things.
Okay, question for you. Yeah. What would you build then? What do you want to tinker?
Oh, damn. I just went not complete. I'm like, I want to do this. Like, of course, because Iron Man, that's where it started. Yeah. But just like cool gadgets make life easier. And also like have fun with it and silly gadgets. Yeah. Like, can I make an automated bottle opener? Can I, random things around the house? Just, I want to be that person.
Inconvenience is like, I have a gadget for everything.
Yeah. Like that, like, let's say I'm retired and that's all I do. Just sit and like build things like, oh, I made this. Oh, don't worry about that. This is automated in my house. And, do something like that, I think.
You have a robot to open bottles.
Yeah, manual.
That's so 2026.
Yeah. No, but I think I want that. And
nice.
To end it, I'll ask. Yeah. Best piece of engineering advice you ever got?
Best piece of engineering advice I ever got. The age-old one, like keep it simple, stupid. Like
yeah,
keep it simple. I'll say the best life advice, actually career advice or whatever, was like talk for yourself, think for yourself, be yourself. Imitation of suicide. So just like just be you.
Yeah.
talk for yourself, think for yourself, just be yourself. Don't imitate. And I feel like as an engineer, sometimes we're like you try, oh, this person's so cool. Like, I want to be this person. Like, no, just be you.
Yeah.
Explore your thing. Do your own side quest. Learn at your own pace. Do things that are fun to you. Like, don't make it like rote and robotic. Like, have fun.
Yeah, I think that's pretty good. And on that note, this is all we have from this episode. We'll see you next episode. This is Talking Design and Engineering.
Thanks for having me, Sin.
Yeah.
Thank you. Thanks to all the sponsors.
Thank you for tuning in. Subscribe to Talking Design and Engineering on Spotify and YouTube, or follow Makelab or Talking Design Engineering on Instagram and social media for the latest updates.